Okay, so let's get into the next part of this video. So looking at the next example, like I said, this is more representative of like what types of questions I will ask you on assessment. So directions here say to let S of t represent a particle in motion given by the function S of t, which is equal to t cubed minus 6t squared plus 9t, where t is greater than or equal to 0. Okay, and we're going to say that our unit of measure for position, so our position S is going to be measured in terms of meters, and our time t is going to be measured in terms of seconds. Okay, so again, we're going to have like multiple steps that we're asked to complete here. So part A asks us to find v of 3 and a of 3. So the velocity at time t is equal to 3 and the acceleration at time t is equal to 3. Okay, so first thing we want to calculate v of 3 is we want to find our velocity function v of t. So velocity is a derivative of position. It's going to be 3t squared minus 12t plus 9. Okay, and then we want to evaluate this at 3. So v of 3 will be 3 squared, which is 9, times 3, which is 27, minus 12 times 3, which is 36, plus 9. So that winds up adding up to 0. So that's going to be 0 meters per second, which means our particle is stopped at that time. Okay, if we want to calculate a of 3, first thing we need to do is calculate a of t. Okay, so that's going to be the derivative of velocity. So the derivative of velocity is going to wind up becoming 6t minus 12. And when we evaluate that at 3, we get 18 minus 12, which makes a of 3 equal to 6 meters per second squared. Okay, on to part B. So part B asks, when is the particle at rest? Okay, so when we say something is at rest, that means like it's asking when is the particle stopped or not moving. Okay, so we want to find where v of t, which is 3t squared minus 12t plus 9, is equal to 0. Okay, so we have a quadratic equation that we're going to solve here. I can factor 3 out of all 3 terms. So when I do so, we get t squared minus 4t plus 3. And that is factorable. It's going to factor to t minus 1 times t minus 3. So that's going to be equal to 0 when t is equal to 1 second or when t is equal to 3 seconds. Okay, on to part C. So part C says to draw a sign chart to indicate the direction of motion. Okay, so again, we did something similar to this in the previous example. So, and part C is going to be really important for what we do in part D. Okay, so if we're going to draw a sign chart to indicate direction of motion, this is going to be a sign chart for our velocity function. And we're going to take what we did in part B by determining when the particle was at rest at time t is equal to 1 and at time t is equal to 3. We're going to put those values on our number line, and then I'm also going to put 0 on the number line in a different color, and I'm going to circle it because that is not a 0 for the velocity function, but our function is only defined for t values that are greater than or equal to 0. So I don't want to test any values to the left of 0 on my number line. Okay, so I'm just going to pick one of the intervals to test. Let's say I pick the rightmost interval, so values bigger than 3. Let's say I pick 4. When I plug them into my velocity function up here, 4 minus 1 and 4 minus 3 are both positive, so that resulting product is positive. The sign on the middle interval is negative. The sign on the leftmost interval is positive. Okay, so that's a sign chart to indicate the direction of motion. Okay, on to part D. So part D, this is going to be a new calculation for us. So part D asks us to find the total distance traveled on the closed interval from 0 to 4. Okay, so we haven't done total distance traveled yet, but I want to talk about total distance traveled. And I want to talk about the difference between total distance traveled and displacement. Okay, so let's pretend, and I'm going to erase this after I'm done, but let's pretend we have a particle in green. Okay, and let's say in the first 2 seconds, okay, so in the first 2 seconds, let's say that that particle moves 3 feet to the left. Okay, so if I want to calculate the displacement in those first 2 seconds, the displacement, which is the change in position, we've gone 3 feet to the left or 3 feet backwards, so our displacement there would be negative 3 feet. Okay, the total distance that we've traveled in that first 2 seconds, so total distance traveled has to be a positive quantity. So the total distance that we've traveled is 3 feet. Okay, so from this point that we've marked in green over on the left, let's say in the 5 seconds after that, okay, so this time in red is 5 seconds. Let's say that that distance in red, let's say it's 10 feet. Okay, so that segment in red is 10 feet. So if we want to calculate the displacement, in those first 7 seconds, how much has our position changed from our starting point here in yellow to where we finished up in red? The position has changed 7 feet in the positive direction. Okay, so our displacement over those 7 seconds is a positive 7 feet. Okay, if we want to calculate the total distance traveled in those 7 seconds, we are going to take 3 feet plus 10 feet, which gives us 13 feet. Okay, now how did we make that calculation? Well, we made that calculation by taking the absolute value of the displacement traveling in each direction. Okay, because when we take the absolute value of this displacement here that we calculated, the absolute value of negative 3 is 3. And then we took the absolute value of this next displacement, which is up here. The absolute value of 10 is 10. And when we take those absolute values and add them together, 3 plus 10 gives us the total distance traveled of 13 feet. Okay, so that is how we calculate total distance traveled. We're going to take the absolute value of the displacement of our particle traveling in each direction. Now, for you to be able to do that, you have to set up a sign chart like we did up above here. Okay, that sign chart is necessary because that's going to tell you where you have to break up your displacements. So the first one is from 0 to 1. The second one is from 1 to 3. And in part D, it asks us to calculate the total distance traveled from 0 to 4. Okay, that little piece in purple is going to be the displacement from 3 to 4. So if we want to compute total distance traveled, it's going to be the displacement from time t is equal to 0 to time t is equal to 1. So that's going to be s of 1 minus s of 0 plus the next displacement we're going to calculate is the one in light blue. So that's going to be s of 3 minus s of 1. We're going to take the absolute value of that. And then to that, we're going to take our third displacement, which is the displacement from time t is equal to 4 to time t is equal to 3. Okay, so go ahead and pause the video and compute the total distance traveled, and then I'll write up the values that you should have found. Okay, so you should have found s of 1 to be 4. So this would be s of 0 is going to be 0. So that's going to be the absolute value of 4 minus 0. You should have found s of 3 to be equal to 0 minus s of 1, which is 4, plus s of 4. You should have found that to be 4 minus s of 3, which is 0. So this winds up becoming the absolute value of 4 is 4, plus the absolute value of negative 4 is 4, plus the absolute value of 4 is 4. So that winds up being 12 meters. Okay, so part E asks, when is the particle speeding up and when is it slowing down? Okay, so the good news for us is we already have the sign chart for the velocity function. We did that in part C. Okay, so the sign chart for velocity looked like this. It's 1, that's 3. We're putting 0 on the number line so we don't test to the left of that. And this was plus, minus, plus, and that's our sign chart for velocity. Okay, we also need a sign chart for acceleration. Okay, so our acceleration function that we calculated earlier in part A, I believe, was 6t minus 12. And just like we did with the velocity function, we want to calculate where acceleration is 0. So that's 0 at t is equal to 2. So I'm going to put a sign chart for acceleration down below here. Okay, so this is our sign chart for a of t. I'm going to put 2 on the number line. And then I'm also going to put 0 on the number line so I don't test to the left of 0. And when I test my intervals for acceleration, if I pick a value bigger than 2, acceleration is positive. When I pick a value smaller than 2, it's negative. So like the way we approach this is going to be exactly like what we did when we did curve sketching. You guys remember with curve sketching, we compared f prime and f double prime to figure out the shape of our function on the given intervals. We're going to do this here to figure out when we are speeding up and slowing down. Okay, so speed up and slow down. Okay, so let's just work from left to right on our graph. So on the interval from 0 to 1, velocity is positive, acceleration is negative. So the signs are opposite. That means that our particle is slowing down. Now, I'm using a bracket at 0 because 0 is not a 0 of either velocity or acceleration. Okay, and velocity is going to be positive at 0, acceleration is going to be negative. Okay, next interval we want to look at is from 1 to 2. So both velocity and acceleration are negative. They share the same sign. So that means that our particle is speeding up. Okay, next interval is from 2 to 3. So velocity is negative on that interval. Acceleration is positive. So on the interval from 2 to 3, velocity and acceleration have opposite signs. So that means that the particle is slowing down. And then the last interval is from 3 to infinity. So both velocity and acceleration are positive. They share the same sign, which means our particle is speeding up. So with these two sign charts here, like we can give a really detailed description about the motion of our particle. Okay, we know that from 0 to 1, the particle is moving forward. So it's moving forward and it's slowing down. The next interval from 1 to 2, the particle is moving backwards and it's speeding up. Next interval from 2 to 3, the particle is moving backwards and it's slowing down. And then the last interval from 3 to infinity, the particle is moving forward and it's speeding up. Okay, last thing we're going to compute here. The directions here ask us to find the speed of the particle each time the acceleration is 0. Okay, so we know acceleration is 0 at time t is equal to 2. We found that out in part E. So if we want to calculate speed at that time, speed is going to be equal to the absolute value of the velocity at time 2 when acceleration is 0. And the velocity at time 2. So if we plug 2 into the velocity function, we get 2 squared, which is 4, times 3, which is 12, minus 12 times 2, which is 24, plus 9. So that's 21 minus 24, so that's negative 3. And the absolute value of negative 3 is 3 meters per second. Okay, so these are the two videos that I covered in class, in the other classes. And then I have another video that I want you guys to watch for homework. And then we're going to do one more example in class on Friday. So I want you guys to watch the video for homework. That way you have some time to review for your midterm that you're going to take on Wednesday of next week. You'll have some time to review for that midterm in class after I go over the last example. Okay, so that's it for today, guys. Hope you all have a great rest of your day.